Good morning, ladies and gentlemen. Let me first greet you on behalf of the World Academy of Art and Science. And at the beginning, I will say also a few words about the Academy, though I am fairly sure that most of you do know enough of the things about the Academy. But let me also greet you on behalf of the Inter-University Center, which is the building where we are now. And I will also say a few words about the Inter-University Center. And of course, the third organization involved in organization of this is the Dag Hammarskjöld University College for Diplomacy and International Affairs, and I will say a few words about that. And of course, this is the city of Dubrovnik. In many ways, a very well-known city to most of you, and I would not spend too much time describing the city of Dubrovnik, except of showing my personal connection to the city of Dubrovnik, which might be of interest to some of you. I was not born in the city of Dubrovnik, but I was raised. I was 3 years old when my family moved here, and then I lived through the entire period of the Second World War and through the beginning of the Cold War. So I have two wars that started and that took place in this city. And then when we had another war, which was in the 90s, then Dubrovnik was under siege for quite a long time. And of course, one of the characteristics of Dubrovnik, as you have looked around maybe, Dubrovnik is really almost an island in a way. It's the only part of Croatia which is disconnected from the other part of Croatia. So Croatia is not a contiguous state, but in order to come from Zagreb to, let's say, Dubrovnik, or from Split to Dubrovnik, you have to cross through another country. That other country is Bosnia and Herzegovina. Now you may actually ask who is this devilish person who has arranged the country to be split in two parts, and the devilish persons were actually the nobility of Dubrovnik. And the reason why they did that, they sold this part of land to the Ottomans, rather than having the border together with our Italian friends, with the Venice, because obviously they hated Venetians more than they hated the Turks. Really, it's not like that, but, they had, unfortunately, all around, much border with Turkey, and so they said one border is more than enough. Why should we have those Turks and the Venetians? Now, of course, on top of that, one has to really appreciate that while Turkey was during all of this time essentially an empire, bigger and bigger, more and more powerful, because Dubrovnik was an independent republic, started in the beginning of 14th century and ended with Napoleon. Napoleon actually conquered Dubrovnik in, more precisely, his Field Marshal Marmont actually walked into Dubrovnik and occupied it, and that was, I believe, 1804 or something like that. Now, during all of this time, of course, the Ottoman Empire was there, was not still on its decline. It was not the sick man on the Bosporus as it became later on. Now, Dubrovnik is an interesting city from the point of view of governance, and in this course we will have a chance of discussing governance from time to time, because actually Dubrovnik has done two things. One thing is that the Republic of Dubrovnik had more consulates and diplomatic representatives in the world than Croatia has now, showing, of course, how important international affair for Dubrovnik was. And it was very important also in terms of trade. So they were all the time trading, all the time trying to be very peaceful and so on. And the walls that you have seen have actually never been used during the Republic of Dubrovnik. The other very interesting thing is that they did something which really is overdoing what European Union is as at the moment. As you know, European Union changes, it rotates its head of the European. The structure of the European Union is a complicated one, but the real power of the European Union rests in the sovereign states, in the 28 sovereign states, okay? And then, of course, what is done is that each half a year, this rotates. So I think currently is Italy, right, if I'm not mistaken. And then, I'm not sure whether it goes alphabetically or not, but it goes with some strange procedure, and it rotates every half a year. The Republic of Dubrovnik did it much better. They changed actually a ruler of Dubrovnik called Knez, or a duke, each month. And there was only one who wanted to stay longer, and they killed him. So basically, they absolutely consider that it should be very, very, democratic in this sense. When you look at the rulers of Dubrovnik, then you find out that though it is supposed to be very democratic, the position of the Duke was only within about maybe 40 most important families of Dubrovnik, so not really all the population. Now the same story more or less was Venice, and Venice was for many cases, of course, the role model for Dubrovnik, except that Dubrovnik slightly adjusted to whatever it was, because Venice was not that close to the Turks, though Venice, of course, as you know, was in control of present Cyprus. It was fighting with the Turks there, and so on. So much about the city of Dubrovnik. This building is the seat of the Inter-University Center, and it has been the seat for the last 42 years. 2 years ago, we celebrated the 40th anniversary of this center. It has been initiated by, at that time, director of the University of Zagreb, Professor Supek, who happened also to be a leading physicist and my professor in physics. Before being the center of the IUC, this was the elementary school called, and often you may still hear people in Dubrovnik referring to this as Preparandia. Preparandia comes, of course, from the Latin English word to prepare, right? And the idea was that these people would be preparing, so it was a kind of the elitist elementary school, where, of course, teachers were from the highly trained positions and so on. Okay, now a few words about the World Academy. The World Academy is also something that had recently its 50th anniversary. It was founded in 1960. It was founded by a number of it started actually in early 50s, and there were a number of outstanding people involved. Among them, one was Albert Einstein, and, he later on in this decade, in 55, he died. And this is the list of some of the people who were engaged in the foundation of the World Academy. So the entire period, the entire decade of the 50s was really a very eager period for the establishment of the World Academy. And of course, establishing the Academy is not an easy thing, number one. And number two, let's not forget that this was the period immediately after the Second World War. So what do you see here is that the time when actually the Academy was established, it had 40 founding fellows, and here are listed the numbers of the original fellows from various countries. 14 from the USA, 6 from France, 6 from the Netherlands, 5 from UK, 3 from Israel, 2 from Belgium, and then 1 from Italy, India, Denmark, and Canada. Now, you immediately see several things, and I was referring to this sometimes as the Academy of the Victors, because obviously Germany is not here in the list, Japan is not here also. Now, since it was really done in the period which was already the period of Cold War, also the USSR was not there, and Poland was not there, and the Czech Republic, and so on. So all of these actually were where one would expect this to be, were not present. Now, let me immediately say that there is a profound difference between the World Academy and many of the national academies that you have nowadays in the world, primarily because most of the national academies, with few exceptions, one exception is the Italian Accademia dei Lincei, are formed in the 18th and 19th century, and this is the beginning of the national states. So even the French Academy, which was founded under Richelieu, has as its most important task the question of the language. And then similarly, this is throughout, all right? Now, the question of the language is by no means a trivial thing, and it's, of course, very important for each of the states. Let me make a comment with one academy, of course, which was crucial for the Inter-University Center, and this is the Yugoslav Academy. First, of course, its original name is really Yugoslav Academy, and it was founded in 1861. Now, this is roughly 60 years, 70 years even, before the country of Yugoslavia was founded. So this was an example of an academy which was much, much ahead of the situation that it was, because in France, for instance, it was a French academy. Let's say Austria, it was an Austrian academy, and so on. Now, there are several exceptions that are worthwhile to discuss. One is Germany, that has many academies, and this is still a problem in Germany, and now what has been done is that Leopoldina is considered to be primus inter pares, and of course, as you know, Leopoldina, having the name after the Emperor Leopold, who was not a German emperor, he was the Austrian emperor, and this, of course, is another of the odd things. But that academy, which is located in Halle, close to Dresden and Leipzig, is, of course, an interesting academy. Now, since the history of the academy is very, very important, as I want to stress, but the academy, the World Academy, is the only global academy. And at the meeting in October in 1956, one of the crucial persons, Hugo Boyko, who was the second president of the academy, the first president of the academy when it was founded in 1960, was Lord George Orr. He was the Director General of FAO. He got a Peace Nobel Prize for his effort in really doing FAO as it should be. But Boyko, who was really a very important man, here actually is the quotation of what he wrote at the time of this first conference, which was in 1956. And then the whole story, and I'm just mentioning the article number 3 of the current constitution of the World Academy, underlines what are the objectives. Okay? Now, one important thing, as I said, when it was founded, it was 40 members. Among these 40 members, they were citizens of 10 countries. What do we have now? We have now some 700 fellows. The number is increasing. But then there is a philosophy that we want to push in the World Academy, and the philosophy is we want the academy, and this is another distinct difference between World Academy and all of the other academies. What is the role of the academy? Certainly to be a role model, right? This is one of the basic things. Now, for any country, even a huge country like United States or India or China, these outstanding people, whoever they are known throughout because of various things, the media, just because of their role that they have and so on. In the case of the world, you may have somebody coming from some country and basically people don't know who they are. For instance, since I teach throughout my life, I actually found examples that students, not only that they don't know who Hitler was and Mussolini was, but many of them don't know who Niels Bohr was, and some of them would put Newton to be almost our contemporary, so there is a remarkable lack of these things, and it is quite clear that you really cannot hope that the fellows of the World Academy, regardless whether there is 40 or 700, would be known throughout. So basically, the only way to do this is to demand fellows to be active. So becoming the fellow of the World Academy is not just a distinction, is not meritocracy, as it is throughout all of the academies of the world, but is a demand that they are active and remain to be active for the considerable time, which means that they have to have at least 2 activities. One is in connection with other fellows of the World Academy, and second, in connection with the basic questions addressing the humankind, and therefore the primary role of the World Academy is not to focus on some scientific disciplines, but really go beyond that. And that's another difference from the National Academy, because if you have, let's say, a famous chemist in any country, a Nobel laureate, let's say, there is no doubt that that Nobel laureate will be elected in the National Academy. On the other hand, that may not be enough of the condition to be elected in the World Academy, because that person may not just be active. As I said, throughout the history, there are no attempts to create another World Academy, and this is very good. There are academies that tend to engage more than just one country or group of countries. The most notable case is the European Academy. And unfortunately, there are 3 European academies. There is also an academy of the Islamic countries. There is also the academy which goes under the acronym of TWAS. It was the Third World Academy of Sciences, founded by Abdus Salam, who at that time was already the fellow of the World Academy. He was, I believe, even a Nobel Prize winner when he founded the Third World Academy. It is located in Trieste, and of course we have very intimate and strong connection with the Third World Academy. But the Third World Academy, as the word says, though we have excellent connection, and many outstanding academies like l'INCEI, Académie Française, Royal Society, and National Academy of Sciences have good links with TWAS. TWAS, for instance, cannot have an American citizen among its fellows, nor a British citizen who is not living actively and working in the so-called developing country. Okay, so this is the distinction. On the other hand, let me stress that, of course, the World Academy, as European academies, as TWAS, as Islamic academies, are the academies of individuals. There are, of course, association of academies, and there is the association of all of the academies of the world, including World Academy, called Inter-Academy Panel and Inter-Academy Medical Panel. So this is a kind of the situation. The World Academy had so far 13 presidents. Our current president is Heitor Gurgurino de Souza, and whatever I said so far was actually he would have said if he would be able to come here, but unfortunately he was not able to come here, and now what we do, we try to actually optimize our own time in such a way that, of course, we try to be wherever is closest, and obviously Dubrovnik is fairly close to me. To Gary, everything is closed, so Gary comes to almost everything, and is close to Alberto, so Heitor missed it. Heitor, before being elected as president, he was for a long time the vice president of the Club of Rome, and before that he was director of the United Nations University, and before that was a rector of the university in Brazil. He's from Brazil. Of course, you met Gary. Gary is the chief executive of the World Academy. He used to be the chair of the board, but we have a limited term on all of the duties, and you will see this evening or tomorrow morning a current chair of the board, Professor Winston Nagin, who is arriving this evening. So much about the World Academy. And of course, let me just say that previously you have seen the program of our schedule. Now we have the idea is in quite addition, of course, of these informal meetings here. The idea is to discuss, to talk. So first, of course, if anyone wants to say something and interrupt me as I speak or as anyone else speaks, just raise your hand, and of course We have also now connected, 40 people?
We have 3 more fellows online. We can welcome Ashok Natarajan, Carl Lindgren, and Sasha Popovich.
Popovich are online.
And we have another 5 or 6 8 participants.
Online.
And Ranjani, who's a junior fellow.
Yes.
Also.
Okay. So, I mean, it applies to all of you, and it applies also to those who are online. If you want any interruption, please ask the question. So, before as you see, what we have scheduled to do is the talks that I gave, or the description or welcoming on behalf of these organizations took these 20 minutes, and now I will proceed to the next thing. But if there are anything that anyone would like to ask more about the World Academy or anything else, please, we can do this right now. So these are some of the ideas as we will proceed. Then we have Gary, and of course, as I suggest, everything is rather informal. The most important thing is that we hear your opinion, that all of us interact rather than formal presentations. By the way, all what I said is on the PowerPoints. I added a few things here and there, but these PowerPoints will be made available. Right?
Not only the PowerPoint, but the whole meeting is being recorded with video and audio, and that will all be put up on the web a few days after the sessions. So
you'll be able actually to even hear what any one of us said, though it was not in the PowerPoint.
Including the discussion.
Yes. Okay. We had that actually 2 years ago when we had the meeting here in this premises on elimination of weapons of mass destruction, organized together with European Leadership Network. Right? This was also all on our web that we put that. Right? Okay, can we proceed to the essential topic, actually, that we have? And the topic is the need for the new paradigm in social sciences. Now, I will start first, since I'm a physicist, with something which is extremely simple, namely the situation in a paradigm change in the physical sciences. Okay? And I will convince you, I hope in 5 minutes, why physics is so easy, while, of course, social sciences are extremely complicated. Okay? First, when you look here, you have human being and you have the universe. Okay? Human beings deal for us something very simple, is something of the order of a second to 100 years. Okay? We can really feel our pulse going at roughly on the 1 second rate, and then of course we live 100 years, so this is something quite okay. In terms of the distances, 1 centimeter to 1 kilometer is perfectly okay. The universe that we observe is much more different. It goes in time from something very, very short, 10 to minus 24, which means 24 zeros and then 1, which is incredible. Then it really extends to 13 billion years. Now let me call your attention on really the number which I wrote. Is 13.798 done with the accuracy of 0.037. Enormously high accuracy. Is this just blah-blahing, or this is the reality? This is the reality. We really do measure short time intervals on a level of 10 to minus 24 seconds, and we really do know that our universe is this old. This is the result of the recent announcement of the famous Planck satellite that has been released, I believe, in March of this year, so quite recent, and you see it's really known quite accurately. Similarly, in terms of the size that we are confronting, we are really measuring something as small as a fraction of the meter, not nanometers, but much, much less than that, million times less than that. And then, of course, there is even a question whether the universe might be infinite or finite. If it is finite, then we speak about something which again is 1, then followed by 27 zeros, and all of that expressed in meters. So incredible size. And then an estimate of the number of the stars. So we have all of this very, very huge. Now we could go on with this, for instance, and we could see another thing which is relevant, namely the density, right? Our density is roughly the density of the water. This is why we can swim easily, right? If we would be much more dense, we would have very much difficulties. Okay, so our density is the density roughly of the water. What is the range of densities? There are stars, the so-called neutron stars, and their density is millions of million times higher than the density of water. And similarly, there are part of the intergalactic domain where the density is millions times less than even the density of air. So, okay, we as human beings, with our sizes and so on, are attempting to describe the universe, which is much more complicated. Okay? So no wonder when we sense it, when we describe it, that we were almost a priori, it was clear that we will have to undergo, this description will have to undergo a profound paradigmatic change, because just is a different story. Okay? Now, who we are, and what are our basic characteristics, and how these basic characteristics of human beings have been molded. Obviously, and now this is fairly well established, just like these numbers are fairly well established. We are in a process we are children of an evolution. And if we take this assumption of the evolution, then everything becomes much, much simpler. Okay? Now, of course, you could always go to other options and argue, for instance, that after all, and we will come to that discussion, is the theory of evolution something which is 100% correct? Obviously not. Neither is our understanding of the universe, by the way, 100% correct. Science is not a fixed dogma. Science constantly changes. But in order to survive, since we are not very strong, we are fairly weak among the animals. Not even our senses are that special senses in any way. So we had actually to use. Okay, this is Mura joining us. Janani, will you help her to get connected? And we will make a little pause now, and maybe this is the time if you want to ask any other questions while Mura catches up with the rest of us. Okay, fine. All right, then we go. So obviously our big advantage that we have in terms of evolution is curiosity. We are curious, and that is very, very important. And then as a next step, of course, is from this curiosity is developed our sense of conclusions, cause and effect, what Aristotle called sapere aude, namely the desire. He starts his metaphysics with the sentence which says, all men by nature have a desire to know. Okay? Now, let's be careful from the very beginning. Human beings are not only rational, human beings are irrational as well. Human beings are social, and in this process, human beings develop values, cultures, and a whole series of social structures. Okay? As you see, we do develop social structures. Now, of course, we don't make the universe, right? The universe is there, independent of us, okay? Now, several of quotations. The famous quotation by Einstein, he said the most incomprehensible thing is that the world is comprehensible. This, of course, is not a priori clear that we can comprehend the world, and that is the question which we know is applicable to the physical laws, but there is a question whether this applies to the social laws or not. Martin Rees, who is the so-called royal astronomer, the head of astronomy in the UK, who was the president of Academia Europea, at the meeting that we had in Liverpool, said, are we capable of understanding the physical universe? And that is, again, one of the important things. Now, Vicky Weisskopf, former director of CERN and a well-known physicist, argued that actually the development of physical sciences, so let's stick to physical sciences, went from general question and unity of science, okay? This is the famous question, starts with the famous question of Thales. How and from what is the world made? Okay, this is the most general question that you can possibly make. And of course, when Thales asked this question, we went nowhere, okay? So we spent hundreds and hundreds of years contemplating on all of that, and then essentially if you go from Thales to, let's say, Galileo, that is 2,000 years more or less, then at the time of Galileo, we started asking simple question. If you have a ball, if you have two different objects, let's say, would they fall at the same time to the earth or not? And of course, Aristotle, who did these experiments as well, erroneously concluded that heavier objects are falling faster. As well as he concluded a number of things, other which are also erroneous. He concluded that in order to have any motion, you have to have the force. Okay? Which of course we know both things are not quite correct. So what happened is that natural sciences went from unified to a variety of sub-disciplines. And this was the time, somewhere there at the 16th, 17th, 18th century, where you could to some extent speak about mechanics, about optics, quote-unquote chemistry, though they didn't call it that way, but it was essentially chemistry. It was expressed in, for instance, finding something which would allow you to transform ordinary metal into gold, or to get you a potion that when you give it to somebody, that person would fall in love with you, or that person would live forever, you know. So basically this is the beginning of chemistry and, if you wish, of biology. Now, of course, astronomy was extremely important because it was connected with forecasting. And there is no doubt that present astronomy has its deep root in astrology. Okay? So then, as I said, science went through this part, and then physical sciences, and then went into a variety of disciplines. And now that continues on, and is being strengthened by an enormous advance in technology. Now, there are two important concepts about the technology. First, until roughly the middle of the 20th century, technology was ahead of science. We, for instance, were mining and had zero knowledge about metallurgy. Right? We were doing a number of things and had zero knowledge about thermodynamics. Thermodynamics is a child of the second part of the 19th century. So technology was ahead of science. It all changed in the 20th century. Now you can hardly think of any technology which is not already deeply rooted, started in science. Again, this is what I call physical sciences, okay? So what do we have? We have first a variety of new scientific disciplines which essentially come by merging. For instance, the current president of the Croatian Academy is a nuclear medical man, okay? Nuclear medicine did not exist before 1940. It essentially started with the discovery of the radioisotopes, the radiopharmaceuticals, and so on. So this is Elena Curie and Frederic Joliot, this is that time. Then there are questions, for instance, like bioarchaeology, or even astronomy and archaeology, for instance. Then there are disciplines like the scientometrics, which are there helping to somehow assess science. Then enormous advances in technology, and as I said, they are all very deeply rooted in science. For instance, ICT obviously was not possible before a tremendous development in physical sciences. Then in life sciences, just for instance to take the example of the CT, which is now something very standard. The CT really took its mathematical algorithm from the astronomy, because it really was in the astronomy that thing basically developed. It has been pointed out by the historian of science, Derek de Sola Price, that the invention or construction of instruments is essential for the development of physical sciences. And you can go back and see, for instance, the telescope. See, the sky that you see with your naked eye and the sky that you see with the telescope is completely different, okay? The world that you see with your naked eye and the world that you see with a microscope is also very different, okay? So the instruments did play a very important role. When you look now the sky using the infrared, is again different. When you look the X-ray or gamma ray sources, is again very different. So yes, the development of instruments is of utmost importance, and there are two recent ones. One is the building of the so-called Large Hadron Collider at CERN. By the way, the former Director General of CERN, the only one who was Director of CERN in 2 terms, Harvey Chopper, is a member of the Board of Trustees of the World Academy. He himself, actually, when he was director, developed the so-called linear electron collider. Now we have this Large Hadron Collider, which is a big machine aimed actually of trying to understand, and I will come to this later on, the so-called Higgs boson. Okay, I will come later on to this thing. Then, as I said already, there is a Planck satellite, and the purpose of the Planck satellite is to be able to measure the earliest part of our evolution, of our universe, by looking actually at the radiation that comes from the Big Bang. Now, it seems we have evidence that the universe started in a Big Bang, that it started, as I said here, and you have this number, 13.798 billion years ago, when the universe was very small, and then the space tremendously enlarged by 10 to the 26. This is the famous phenomenon of inflation, okay? And then it started still to expand. By the way, and that is another important thing, which is very worthwhile to notice, person who is almost single-handedly responsible for the theory which describes that, and that is the general theory of relativity, is Albert Einstein. Albert Einstein actually absolutely refused the idea that the universe is non-static. In order to make the universe static, he introduced a constant, sometimes in a jargon called lambda constant, which kept the universe static. He refused actually to even answer to the letter of a young Russian astronomer, Alexander Friedman, which was in the beginning of the 20th. And Friedman said, Professor Einstein, your equation actually, without this lambda, actually allow for the universe to expand.
And he said, no, this is ridiculous. I don't want to believe that. He threw that in a wastebasket, So it took several years for him to do this. Then finally, when there were convincing measurements from the United States, the Hubble group, that proved that the universe is expanding, then Einstein admitted, yes, the universe is not stable, and he said, the introduction of the lambda constant is the greatest error that I ever made. Now, unfortunately, one of the problems with human beings in general, and physicists in particular, is arrogance. If you look, for instance, in most of the religious scriptures, you always see that the first sin is really connected with the arrogance. In the Judeo-Christian tradition is the arrogance of the angels who thought that they know everything, and of course God always comes and tells this is not so. In case of Einstein, of course, since Einstein was the greatest physicist who ever lived, God wanted to punish him twice. So Einstein died, and then when he died, it turned out that actually we do need the lambda constant, and that the universe is expanding even faster. So, I always tell to my students, Einstein is this famous man, the only one that I know who made 2 mistakes in a row in the same narrow subject. So making a mistake is nothing bad. As a matter of fact, this is how we teach. Being arrogant, this is very bad, but of course this is part of our nature. We are arrogant to some extent. The other thing which is important is, of course, and that was referred by, at that time, the director of Oak Ridge National Laboratory, Alvin Weinberg, when he introduced something called science and big science. Okay, one would say that the other thing would be small science, but okay, whatever. So what is the big science? The big science, he said, are those projects where really you cannot work unless you have a very large number of people involved in this science. And of course, the role model was the Manhattan Project. Because though it was led by several of outstanding physicists, like Oppenheimer, like Bethe, like Wigner, and so on, like Szilard, the irony is, for instance, that Einstein never got a clearance to come to Los Alamos. He never got a clearance to do this. By the way, Edgar Hoover was always highly suspicious that he is a Soviet spy. He was not a Soviet spy, but as a matter of fact, roughly about 5 years because Einstein died, he had a mistress who happened to work in a Soviet embassy. So whatever that story is, he obviously was not a spy because he didn't know anything about the nitty-gritty details of making a bomb. So a man who wrote a famous letter did not have a clearance. The man who actually initiated the famous letter, this is Leo Szilard, also did not work in Los Alamos, and is also very well known for being a man who proposed in a letter to then President Truman not to drop the bomb to Japan, but to drop it somewhere there on the territory which is not inhabited by people. Truman refused that entirely. And then, of course, the third great physicist, Niels Bohr, when he escaped from Nazi-occupied Denmark, went to England, and the chief science advisor of Prime Minister Churchill introduced the two men, and after about half an hour conversation, which was obviously that everything is exploded, Churchill said, we have to imprison this man. This man is completely dangerous. He speaks about revealing the secrets to the Soviets and so on. And of course, we are friends with the Soviets, but no secrets to the Soviets and things like that. So much how these things are. But okay, now, as I said, the Manhattan Project is a big project of many, many people working there. And now what we have is, if you ever take any journal in physics, you can see that back when we started with something like Physical Review, the number of authors has been 1, 2, 3. Many of Einstein papers are just a single author. Similarly, many papers in quantum physics at the beginnings of the 20th century are also single authors. Now, when you take an article in a Physical Review, then there are 2 pages of authors and half a page of publication. And sometimes even, not even the names of individuals, but it says the group from Berkeley, the group from Moscow University, the group of so-and-so. And so this is the phenomenon of the big science. Now, this is in physics, started in physics, but is no longer a phenomenon just of physics. This is happening more and more because of a number of reasons. Some of the reasons is that in order to take to do some research, you have to have specialization. You have to have a person who really knows electronics very well, who knows magnets very well, who is very knowledgeable about making certain things and so on. So this is another very important thing. I will come to this because it has an utmost importance for our life in general. As I said in this famous first comment when I said that we are thinking both rationally and irrationally, this question was obviously known for quite a long time. There is a famous sentence of Blaise Pascal in his sentences, and this is actually that sentence, but let me remind you that this sentence was based on his approach to the issue of God. He argued at that time, and that might be the view of theology today, God is not is not a concept to be perceived by your rational, but essentially by revelation, which is essentially the art, and so on. Then 2 other famous statements by Einstein, which of course we come very frequently to discuss. All right, now, as I said, what we have now, and this is from the last year, we now know that the universe, and let me say, this is our universe. We don't know whether there are other universes, and I will tell you why we think there are other universes. That in this universe, we understand less than 5%. This is the ordinary matter. This is you, me, the light, the stars, the galaxies, all of that is 5%. Then there is something like 26.8%, which we call dark matter because we don't know what it is, except that we know that there is there. And then there is 68.3%, which again we don't know what it is, which is the dark energy, and this is related to this famous second mistake of Einstein. Then there is this question of inflation, and the easiest thing to see inflation in physics is that this is a phase transition. And what is the phase transition? Is, for instance, the transition from water to ice, or from water to gas. So this is what the phase transition is. Okay? And this March 17 is that we actually obtain evidence in this direction. But this is very, very recent, but still is highly questionable unless proven more accurately. Now the very important thing, the universe that we are studying, this physical universe, has the feature of having components. This is back to the Thales' question, from what in and in which way, and from what are particles. And these particles have not changed for the 13 billion years. And laws have not changed for 13 billion years. There is a possibility that they did change during the time of inflation. Very likely, John Archibald Wheeler, argued that they are changing then. But this is not a microsecond, this is not a nanosecond. They were changing there in a time interval much, much smaller than that. But whether or not, we don't know. Now, do we know that, you can ask a question, how can you tell me that these laws did not change? I mean, after all, our history is barely 5,000 years. Yes, but we have done the measurement, and the measurement very clearly show that the laws of physics did not change for these 13.7 billion years. Now, at this point, I think it's very important, since our subject is not the physical sciences, our subject are social sciences, that you look at the social sciences. Okay? Did law change in the case of the society? The law tremendously changed. So it's a totally different story that we have. Okay, now back to, again, physical sciences. What happened with the physical sciences? Physical sciences, starting from essentially the time of Newton, tend toward unification. And we are quite successful in unification. First, we unified what I like to call heaven and earth, namely the phenomena on the earth, like this phenomenon, and the movement of the sun and the earth and the moon and so on, are through the Newton theory of gravity unified. We know that there is the same force of gravity throughout. Okay? And that is a very simple 1 over r squared force, which we very often see everywhere. So it's absolutely almost intuitively correct. Then, in the 19th century, there were fields totally different. I mean, light, for instance, is one field. The other field is magnetism. You have a magnetic needle, for instance, which was known to the Chinese and to the Indians. Then you have electricity, again, known for a long, long time, but then only the 18th century, 19th century made in some form. And this was unified by the Maxwell equation, all of them coming together. So instead of electricity, magnetism, and optics, we had the electromagnetic sphere. Then was the quantum physics, which came at the turn of the 20th century, which is the unification of physics and chemistry. Now there is, and then of course, astronomy, geosciences, nanosciences, all of that was unified. And what does it mean? It means actually that once you have the basic norm, the basic equations of relativistic quantum physics, you can understand everything. So chemistry is reducible to physics, okay? All of the physics is reducible to these equations. This does not mean that you will not need chemistry, on the other hand, obviously not. This does not mean that you can, even on a simpler level, that you can do everything by solving the Maxwell equation, because this is much, much too difficult. And most of the people trying to put electric wires and so on will do this quite on a technical level. But at least we have a solid foundation of the unity of physical sciences. There is a tricky part of biology. Biology is very, very tricky, and this, to come back to one of the things that the World Academy initiated now, and this is the World University Consortium. Let me say that the crucial role, by the way, was in forming this was played by the talk that Giannani gave at the conference that we had in Geneva, that we organized together with the UN office in Geneva, and Giannani gave there a splendid talk, which was actually the beginning of the idea that we should come back to our founding fathers who said that the World Academy should really go to being the university. And somehow that idea of the university education is of utmost importance. Now let me make in parentheses two things, of course. The importance of education, by the way, is deeply rooted in our culture. Go back to the Chinese, and when they speak about the 3 greatest sins, one of the greatest sins is bad education. Now you can see how guilty we are, ready to go to hell with the education that we have throughout the world, So education is of utmost importance. Now the World Academy is doing one more thing, because when you look at the UN, and there in the so-called Millennium Goals, education is emphasized. But that education is stressing on essentially literacy. And somehow we thought that the crucial aspect is the higher education. We may be wrong, but anyway, this is where we are. Okay, so now coming to the question of biology. Why did I say that biology is a special case? Because essentially all of the biologists deeply believe that biology is essentially quantum physics plus theory of evolution, and there is nothing else. There is a famous book by Jacques Monod, a biologist, Nobel laureate, called Chance and Necessity. And he said everything is just chance and necessity. This is the statement of Democritus, so obviously an atomist. Basically at that time we could say him a physicist. And word chance and necessity is just nothing else but quantum physics. I mean, once that you have what is called in a jargon Hamiltonian, so you know the particles, you know the forces, then you calculate, this is the necessity, and then it comes the famous statistical interpretation of quantum physics, which, by the way, Einstein never believed. That's another thing, that he was deeply, confused guy, very great physicist, but with a number of serious prejudices and mistakes. So once you take that, then you have the chance, and that is it. And then in order for everything to make sense is evolution. Now, is the evolution final word? No, and we'll come to that later on. Okay. Then in the 20th century, there is the unification of the electromagnetic force and the weak force, which was accomplished by Abdul Salam, by Carlo Rubbia, who made the experiment, by Weinberg, and by Gletschel. And then we are now working on what is called the grand unified theory, which will even include the strong force. And then comes the famous theory of everything, which has this arrogant, preposterous name, theory of everything, but is not the theory of everything. What it is the theory of 4.9%. So this is another hit to our arrogance that this is the story. Okay, now somehow, because of the development of science in general, because of something that came out of the sheer necessity, and that was the need to do some measures, just in order to survive. What does it mean to survive? You had to know what will happen with the Nile, what will happen with the other rivers. You will have also to agree whose land is this and whose land is that, and you depended on the trade and so on. Human beings depend on this trade very much. The geometry developed quickly, and it was through the work of the Greeks, starting from the 6th century BC, and then culminating in the Euclides, in the work of Euclid, who actually formulated the geometry. And he formulated the geometry in a following way. He had definitions, and then he had rules. Okay? And then he had consequences of the rules. Okay, the rules were very, very simple. And it had 5 basic rules, sometimes called postulates. Okay? These were almost intuitively clear what they are, as were the definitions, and then everything else came out of this. So this was the famous axiomatic approach to geometry. And since everything came so beautifully, this remained as a model for all of the sciences. So much so that Spinoza, I believe in the 16th century, wrote his Ethics, essentially based on this axiomatic approach. And it did not work very well. Okay? Then we have classical mechanics, which can be put in the form of the axiomatic approach, And it worked very well, and this is why classical mechanics is one of the dullest subjects that you can possibly have, but you need to have it if you want to be a physicist, because then you learn there all the important things. Okay, so how about everything else? Now we go with those things which are much more difficult. A simple category would be some of the cognitive sciences, though cognitive sciences had enlarged much more, but I have put here logic, philosophy, and theology, and you see that they have the ancient origin, the law, which has also ancient origin in Taxashila, Varanasi, Kanchipura. Kautilya's Arthashastra is really a forerunner of Il Principe. And then it comes in the 20th century, the definition of what science is of Karl Popper, where he says science is what can be falsified. So obviously physics can be falsified. You can prove that the standard model is incorrect, and this is what physicists are doing all the time. Now, how you can prove that law is falsified? You change the law in any parliament, right? But I mean, this is not falsifying it. This is just changing it. The same story in economy. Also the history and so on. So basically, this is very, very different story, how this is going and developing. And then, of course, social sciences develop in essentially has two phases. One phase again, just like natural sciences, all the time back to the Greeks, Hindu, Chinese, Mesopotamians, and so on. And then they start in something like 16th, 17th, 18th, mainly 19th century. Economics starting with mercantilism, physiocrats, and so on, and basically 1776, the wealth of nature, the wealth of nations, is really the pivotal argument. And then it goes to, of course, the first Nobel Prize winner, Jan Tinbergen, who, by the way, originally was a physicist. His brother is another famous biologist, also a Nobel Prize winner. It's interesting thing that Jan Tinbergen actually was a founding trustee of Economists for Peace and Security. So the dimension of peace and security is strongly linked with economy, which sometimes economists forget nowadays, but is essential and essential thing. And then, of course, with Kuznets and so on. Then there is a story of sociology, and again, you see Confucius, Plato, and so on, and then from Durkheim, Marx, Weber, and all of them. Psychology, which of course is one of the most difficult subjects, going from Wundt and James and so on to Gestalt, and again Thales, Hippocrates. Linguistics started again with India, Panini, and again now going to Chomsky. Then very recent development like uncertainty and game theory. Game theory now became extremely important. Is a work actually which was partly developed in connection with building the hydrogen, building the nuclear bomb. So definitely is John von Neumann there. Then the complexity theory, which is maybe the best book, is the book written by physics Nobel laureate Gell-Mann, The Quark and the Jaguar. Quark being one of the constituent particles of the proton or the neutron, and Jaguar, of course, being an example of a rather complex animal. By the way, started by our member of the board of the World Academy, Raoul Weiler. We had one of the seminars devoted to complexity theory, and we still have to work more on that. Now, there is, of course, the chaos theory, which again should be mentioned there, and you can, of course, possibly you noticed that I did not mention mathematics here. Now, mathematics has a unique position. In a way, of course, you can look at mathematics as a tool. On the other hand, there is a number of things which link this together with logic. And the thing which links it with knowledge, with logic, is the famous work of Kurt Gödel. Gödel actually
approached the question of the proof and the truth, which was there also at the time of Poincaré, Peano, and so on, all of these great men. It's a very, very complicated thing. And he is famous for proving, within a very narrow subject of mathematics, the so-called number theory, proving that there are truths which you cannot prove. And this question is really a very, very profound story. By the way, of course, he, as many other famous scientists, fled from Germany and went to the United States. At that time, he moved to Princeton, where Albert Einstein was also. And, of course, as both of them were famous scientists, and they were living in the United States, they wanted to become citizens. So Einstein was already a citizen, and Kurt Gödel was supposed to become a citizen of the United States. So Einstein, his good friend, accompanies him there to the office where he's supposed to accept this and sign. And Gödel tells him, I was just studying, which is a requirement, the American Constitution. And the American Constitution, I can prove it to you, has logical inadequacy. It's clearly wrong. Einstein, who after all was not a logician but a physicist, told me, please shut up. Don't mention this. I mean, you are right, but if you say it, you will never become a citizen. So finally he convinced Kurt not to say that, and Kurt Gödel, just like Einstein, became the citizen, and this is just, a footnote without being properly done. Okay. Now back to what we want to do. We did previously said we had human beings and we had the universe. And the universe did not change. Okay. How about the human being? Did human being change? Yes. Human being change. And there are two ways how we change. We change biologically, and here is the description. In the last 10,000 years, we did change reasonably, and as a matter of fact, even some of the illnesses, like, for instance, diabetes, might be the reason of some of these changes. Now, the other story is we have very much extended ourselves. It started very early with wooden legs. I mean, that was already, almost prehistoric time. Then the eyeglasses, which are more than 1,000 years old. Then we have now, in this century, we have pacemakers, implants, and so on. And then we have the transplantations. And then this is what is going to happen in a couple of years, and we already have synthetic biology. So, yes, human beings will be changed. All right? Now, what scale is this? This is scale of the order of years and 10 years, okay? The universe did not change at all, virtually. Now, how about the society? How fast is that changing? This is also changing very, very fast, okay? Because only some of us use eyeglasses. Only some of us have pacemakers. Only some of us have transplants. But we all live in a world with computers, with mobile phones, with air traffic instead of carriages, and so on and so on. So we live in a world which changed tremendously. And this is one of the very, very serious problems. Now, as we said before, what characterized human beings, because we are social animals, but also on a more elementary level, are values. And it was already said by Darwin in 1871, but became appreciated only recently, that actually global world is what is our primary link. And we have to believe in this. And this was then repeated by the Nobel laureates. And then let me give you what I believe are several important numbers. In one of the articles in our journal Cosmos, I put them down. One is number, we have only one Earth. Now be careful, you can say, there are studies, it's a so-called famous Drake formula, which asks the question, are there intelligent creatures in our universe? And most likely there are intelligent creatures in our universe.
But we, of course, have no contact with them. So at the moment, we are stuck with this earth. And the idea that we will do what our ancestors did when they moved from Africa and settled the entire world is not very likely. It's not that easy for us to colonize the world. We are already in this phase, and mobile phones are the examples that we are there. But in order to make a moon or Mars or Jupiter or any other artificial satellite a place where we will go will not be an equivalent of America or Australia or anything like this. Then there are 7 billion of us. Then there are 5,000 different cultures, and they are as important as different species, and the number of different species just on the eukaryotic species is of the order of 10 millions. Then there are 200 sovereign states, and then there is a question of governance there that comes as a very important question, and we will be coming to this question of the number of conferences organized by us in the future, and then there are several millions of organizations, starting with the NGOs, to academies, and so on. There is an important question of the laws of nature and laws of society. We won't go into these details, but whoever is interested are important books by Rorty, by Feyerabend, and so on. When Winston Reagan comes, he will be discussing more about the law, so we will not spend that time. Let me just go quickly on the rather long study of the world values, which started actually almost 40 years ago by World Value Surveys. And this study has been longitudinal, starting from 81, and then actually plotting these values in a two-dimensional, so-called Ingerhard-Welzer cultural map, which I have a number of problems with this map. Personally, is the one from traditional to secular survival values with more self-expression values and so on. And then since it is longitudinal, then you see, for instance, changes. And you see that in Italy and in France, so two fully adjacent countries, very similar countries, both of them Catholic, both of them Roman languages and so on, have shown some changes. Okay, this is rather important. I'm mentioning this and giving the list of what is being done. It's certainly worthwhile when we speak about values, because, as I said, it's a major effort going throughout the world, and is another example of what I called before the big science, because it's a huge endeavor going on. Now, a rather important thing to tell you, a profound difference between social sciences and physical sciences is just this graph, which shows some of the observables, some of the indicators, how they changed. And you see that most of them changed drastically in the last 50 years, in the last 100 years, anyone that you look at, right? So the change is profound. And that is a very important thing. So the idea that we now should have the same economy as perceived by Adam Smith, or is really preposterous, because the world is different. How could we have? That we would have the same political structure as they had. What does it mean? For instance, there is a famous book by Paul Kennedy called The Rise and Fall of Great Powers. It's a different story now, because a great power at that time could be hardly influenced by the small country. Now what you have is that a small country, for instance, something like Sierra Leone, Liberia, where the Ebola started, that Ebola could be dangerous for all European Union, could be dangerous for United States, okay? The so-called big powers. So the situation is really quite dramatically different. The contemporary world now, or actually just looking a little bit, the life expectancy increased by a factor of 2, GDP increased by a factor of 5, freedom and democracy now encompass the large fraction of the humankind, and we have an international system reasonably good under control in the UN. UN, of course, as compared to the League of Nations, is much better, much more stable, and one could say, fine, why don't we continue business as usual, because this is the desired system. But the real answer is no, and we have really strong arguments against, because the ecological footprint is already larger than 1, is now actually close to 1.5. It will reach 2, which means that we need 2 Earths in order to live almost now, and that's impossible. We are destroying the natural capital, as is shown in a beautiful book by Anders Weidmann and Rockstrom. The original was published in journal Nature. And then we have an economic crisis and enormous, large inequalities, which are very bad. Let me show you how this means. This means that in these areas, and this is the biodiversity and this is the nitrogen cycle, we blew out of what is keeping the Earth. Climate change is also very dangerous in spite of several criticism on the climate change. We have a number of dangers that consequences could be really catastrophic, like now the weapons of mass destruction, but also the climate, like the poverty, the pollution, and so on. So a number of really very, very strong things. This is from the paper that Gary and Lord Brown and I gave at the NATO conference, prepared at the meeting here in Dubrovnik and in Zagreb, and then presented at the meeting here in the nearby city of Split. And just to show you where we are, there is something that atomic scientists, or there are nuclear scientists, actually published in a bulletin of the atomic scientists and put on the front page the doomsday clock. And when they put it in 47, they put it 7 minutes to midnight. Then it went to 2 minutes at midnight when both hydrogen bombs were exploded by USSR and United States. Then went to 17 minutes at the end of the Cold War. And now at the beginning of this year was at 5 minutes. But this was before Ukraine, before the Islamic State, before the war in the Middle East. So it might very well be very close to 2. Now, to come to a conclusion, paradigm change in natural sciences. On one side, we have the world, which is unchanging, but we, by extension of our capacity, primarily of our brain, see more and more and understand more and more, and this is the reason why in the physical sciences we have this profound paradigmatic change at the turn of the 20th century. But let me again emphasize that people who are responsible for this change were not aware of where this change will go, and second, when the change moved to show where it will go, they were opposed to this. Both Einstein and Planck really could not live with this thing. Essentially why? Because as it was written, I think it was written by Thomas Kuhn, he said, quantum physics will finally come to be an accepted theory when all those who were trained in classical physics die. So only when you have new guys will this come out, you know. Okay. One lesson learned is an enormous sin of vanity, of arrogance. Okay? Now, how about the social world? We have a static world, which obviously is impossible because the world is changing. It's changing very fast. Business as usual is unsustainable. So the change is inevitable. Okay? This change can be incremental or it can be paradigmatic. We don't know. We have no idea which way it will go. Of course, it can lead us to nuclear catastrophe. We can blow us ourselves, right? As Don Giovanni says in Don Giovanni's play or show, George Bernard's show, to drift is to be in hell. To steer is to be in heaven. So we have to steer. Okay? Now, how about the paradigm change in social sciences? Socioeconomic and political world changes now quite rapidly. And social sciences, of course, are behind describing this changing world. Because the entire structure of economy, even a recent one, Keynes, is really behind what the world is doing. I mean, when Keynes was there, he was still believing that he can control, and he was controlling the famous 1930 affair. You know, they were able to do this. The methodology, the ways how they did it, is out of question now. So this is not acceptable. Now, the world is changing, but how is it changing is not good enough. So, because it's unsustainable. So the paradigmatic change in social sciences actually has two paradigmatic changes, it seems to me. One is to describe what it is now, and second is what it ought to be. Now, that is totally different from natural sciences. You know, you cannot say, I want the universe to be like that. No, I mean, the universe is there. But the world that we are living, the social world, the economic world, the value world, this is something which really is totally different. So now we come to what are the lessons learned. And the first is, and this is a rather deep one, and the Academy will go again into that, you know, a big declaration, starting with the American Revolution and so on, is the question of human rights. And falling into a trap of the Newton's third law of action and reaction, we like to say that there is an equivalent of human responsibilities. But this is not the same, because you cannot say that this is just like action and reaction, because there is no doubt that we have more responsibilities than the 2-year-old child, or a just born baby, or somebody who is, let's say, illiterate or something like that. So this is very, very complex. But basically what it boils down to is the responsibility to live and to assure that our descendants live as well. Second, human beings are social beings living on earth, and the preservation of natural capital is our duty. We have to preserve natural capital, otherwise we have no habitat. The fourth thing is, of course, and this is in all of the cultures, is the famous golden rule. And the fifth thing is that we have to be active. So the sin of not acting, the sin of omission, which, by the way, the Catholic Church introduced in Vatican II, you know, before it was not, but it was introduced in the Vatican II to be a capital sin, is do not miss, do act. It is your responsibility to act. So these are, you know, I use almost the entire time. You have 5 minutes for the discussion, but maybe we can come to other things. So I wanted to show you the profound difference between something which is very straightforward, natural sciences, and the big paradigmatic change that occurred there. And now the paradigmatic change that we have to go here. When you look about the paradigmatic change in physical sciences, what did we learn? We learned that determinism is gone. We learn that space is not what we thought it is. The time is not what we thought it is. Okay? Now, what are the equivalent in the social sciences? Equivalent in social sciences is that governance is not what we thought to be. What was the governance? Governance system of the governance was that there is one king and model of the god, okay, if you wish, and that absolute ruler. No, this is not so. What is it? We don't know. Now you can say, no, but we want to know. We don't want to live with the uncertainty. Now remember, in physical sciences, we learn a lesson that uncertainty is the name of the game. That in spite of this enormous uncertainty, which is the basis of all of the physical and life sciences, you can make predictions which are incredible. 1 in a billion, 1 in a trillion accuracy. So we have to do this. But in social life, we like certainty. Okay? On the other hand, we have to, of course, appreciate that we undergo risk. We will still be amoebas if we would not accept risk as something reasonable. So we, in a way, we have almost schizophrenic personalities, really very, very tricky. Okay, so these are, I'm sorry for this long talk. I think we can still have, and then maybe shift for another time, to hear your view, and of course you can come at any time and express your view. Roberto?
Fascinating. And I fully agree with you that the social science are not keeping the pace of change. But in my opinion, even if the change was not so fast, still the social science have been failing us because they're not like in physics. The social science are very colored politically. The bias that the social science have, the vision of human nature, make them often blind, not only blind, very dangerous. The sociology and the history of social science is the history of prejudice, of superstition, of racism, of gender discrimination. So they have done enormous damage to humanity instead of helping them. And so that's my point.
Carlos?
Yes, let me do some provoking comment. Maybe a bit exaggerated, just to make us think, which is as close with what Alberto was saying. In a somewhat implicit way, what we are talking about, I'm not saying this is explicit. I mean, maybe if I make it explicit, you will say, no, that's not exactly that. But in somehow implicit way, what we're talking about is that natural sciences have been a huge success, which I agree, which is quite obvious. And the implicit hypothesis we are making is that social sciences should follow the same process, should fill the gap, because they are below, and they should fill the gap the natural sciences have been able to fill. This is not at all clear to me in the following sense. First, I don't know if we talk about the same meaning of science. I definitely do not know if what we need is, or if it is even feasible or conceivable to have, for instance, general laws in social science, the way we have general laws in physics, and you describe that term. So that's one point. Do we need, or is it conceivable to have to produce laws in social sciences? Second, I would make a case against the idea that the natural sciences are the references for the social sciences, and maybe one of the reasons why social sciences have not advanced is that the advance of natural science has been very much based on the idea that we are rational, that we are able on the rationality argument, and that we are able to know nature, for instance. And it has worked in nature, but the idea of us being rational has been a huge drawback for the development of social sciences, because it doesn't work for humans. So, and now funny because now neurosciences is getting to the point to say, oh my God, we are emotional people. Yes, we knew. I mean, at a poetic level, we have been knowing that since thousands of years, so sometimes poetic truth is far better and far in advance compared to to scientific truth. Yes, we are emotional, and the idea of the dualism, the idea of separating mind and matter and separating reason and emotions have been very negative, extremely negative for the advancement of social sciences or social knowledge in the last few centuries. And the last comment I would make is that do we know if we will be able to know? Because we're emotional, that's because most of what drives us is unconscious. Do we simply know for sure that we'll be able with our consciousness to know unconscious phenomena? So
Roberto?
Thank you. First of all, thank you for calling our attention on the fact that physics we know deals with maybe 5% of the universe, which implies that physics may change dramatically in the next decades, centuries, which is something important because many people defend the idea that physics, the physics we know is the last step in understanding nature, which is obviously not true. Second, I think that you have presented the two smoothed out version of unification. I'm not a physicist, but for what I understand, there are big problems between quantum physics and relativity. So the unification, even within physics, is not so, there are problems. But I'm more interested in something different, namely, what physics is not able to see. There are at least two problems that are important from the point of view of the social sciences. One is time, and specifically the future. From the point of view of social science and psychology as well, hopes and fears, our capacity to anticipate the future, is something relevant. I do not think that atoms have that kind of abilities. So that's a major difference between what pertains to the material world and what pertains to the living world. Because I think that amoeba, in some sense, they also have some kind of anticipatory capacities. Otherwise, they will not be able to orient themselves in their environment, for instance. And that's one issue. The second issue is what I call the causal openness of physics. A very simple exemplification. We are not able to modify the laws of physics. Obviously not. But we have learned to exploit those laws in order to build up buildings and roads and bridges and whatever. We cannot see buildings and roads and bridges from the point of view of physics. So it means that the causal network at the physical level, in some sense, it's porous, it's open. There can be anything else entering into the not violating laws, obviously, but giving the results physics, the physical world doesn't want to build up buildings and churches and whatever. We build up buildings and churches and whatever. So, because, so far, it has been as if physics is the one container and the social science is the other container, which to some extent is true. But there also are interactions, and it would be worth trying to unfold some aspects of those ones.
Okay. All right. Just comment on some of the things that have been said. First about the prejudices in physical sciences and in social sciences. They are, I believe, very deep in physical sciences. And as a matter of fact, people have been put to death, burned on the stake, Giordano Bruno, just because of answering the question, are there more universes or only one? Which we now still don't know whether there is only one universe or more universes. So yes, these things are, people realize them as being profoundly different and important. I think Carlos pointed out an important question of, first, are we satisfied with the success in natural sciences? By no means, of course. We just learn every time that we really don't know. So physical sciences are not a great success story, though it looks, but there you can define progress. And progress you can define, as Roberto has said, because using them, and of course using life sciences, we make some enormously good things for us as human beings. And that is big things. We build buildings, we build dams, we build airplanes, and so on. Now the point made by Mura at the very end, where she said quite correctly, that yes, there are a number of things changed, but there are, and almost, though she did not quite explicitly said, the moral laws are deeply somehow in us. And yes, I think actually moral law, now that is the question, whether the moral laws are there because of God's revelation, or because of evolution, or because of something, and what are the basis of these moral laws that we have? Obviously, for instance, one moral law that we have for quite a long time, in spite of all of the killings and so on that we did, is the golden rule. We would never come to the idea to kill everybody and to remain the only one on the earth. This would be obviously something that we don't want. So yes, and the question of what is the source of these laws and so on, and of course the question relating to these basic things and the broad aspects of all of the values is a big, big debate, and I really don't know what to do. For instance, when I showed this famous plot, I'm really not impressed by this. I mean, no way. I think this is
too simplistic.
Too simplistic and too complicated. I mean, look. What does it show? Yeah, I mean, what does it show? I mean, I don't know where it is.
You don't get any relevant knowledge.
Yeah, and even if you see these changes, which I showed here, what does it mean? I mean, is Italy going better or worse? Is France going better or worse? What does it mean? I mean, now, the only thing that we do know from this, unfortunately, is that because of these values here, people from here and here are fighting now, which of course is in a way, so stupid. Now the point made by several of you, and I'm concerned because it shows that I failed at presenting the basic message. My basic message is that social sciences should not try to take physical sciences as a role model.
Okay.
That would be very bad. And maybe I should have said that at the beginning. I think putting mathematics, models, computing into social sciences may be more detrimental than good. And our situation in economy, for instance, one thing which I said as a joke, and some of the fellows would remember, I said, there is a huge number of physicists that turn into economists from Tinberger on, and this is why we had the economic crisis. Because actually, it's a joke, but it's not far from the joke, because what we do is we bring an enormous certainty of mathematics, of computers, as if this is bringing the truths. This is not. In one of the later talks that I will have, I will point to this thing, and I think the essential thing is that when we enter into a sphere of social sciences which is much, much richer, then we should take the full complexity of the human being, both rational and irrational, emotions and so on, because when we treat a human being, that human being, as opposed to electron, that is A, constantly, not changing, and all electrons are always the same. Human being today is not the same. As a matter of fact, I'm almost arrogant to say that each one of us, before I started this talk, were a different person than after this talk. Because obviously it influenced you in some way, right? So we are different as a result of these discussions. But how to take this into account? We might be actually victims of putting too much emphasis on rationality in dealing with these other things. And that might be, I hope we will in this course go on and discuss some of these things, because they are really, when we go to specific subject, but particularly when we go to economy, we would have to really go this